Hi, I will be helping you today with translating or transforming quadratic equations or quadratic functions. The minimum point on the graph of the equation y equals f of x is -1 and -3. What is the minimum point on the graph of the equation y equals f of x plus 5? There are several ways to do this one. I'm going to show you a couple of ways, maybe 3 ways to solve it. The first way is the memorization. If y equals f of x and the other one y equals f of x plus 5, if the 5 is outside of the parentheses and if it's positive, so this one we call it the parent function and this is the child function. So the difference between the parent and the child function is that the child is going to go up 5 points. Is going to go up 5 points. Why? Because this is a positive 5. And if this is a negative 5, it's going to go down 5 points. All right? This is one way. The other way is, let's sketch it here so you know what I'm going to be talking about today. This is coordinate geometry. And let's plug the points. The minimum point is -1 and -3. -1 and the -3. This is the minimum point. Which function are we going to graph? In 9th grade or in Math 1, you are learning or you have learned linear function, quadratic function, and exponential function. You have just 3 functions. Of course, there is no minimum point in the linear function, and there is no minimum point in the exponential function, but there is a minimum point in the quadratic function. So we know the quadratic function is going to look like the parabola this way, and of course if you have a minimum, so your parabola is going to be this shape going this way. Okay, now 5 points, if you're going up 5 points, so that is, let me get this color here, you're going to go up 1, 2, 3, 4, 5 points. Your next minimum is going to be this way, so your function is going to be like this. And the minimum is -1 and +2. That's the answer. Okay, -1 and +2. What else? How about if you forget how to do this problem or forget like this kind of property, if when you have a graphing calculator and you want to check with the graphing calculator or you want to do it with the calc. Okay, in order for you to do this one with the calculator, and we know this is a quadratic equation, you're going to set up any equation, any random equation, y1 equals x squared plus 3x minus 4. I'm just putting any numbers, and I know this is going to be quadratic. It cannot be linear, or it can be linear or exponential, but we just don't want to get there. It's like totally different thing. We're looking for the minimum, which is quadratic. y2, the difference between y1 and y2 is the translation here of +5. Well, what you do is just rewrite the equation one more time, -4, and you add the 5. Let's simplify before you put in the calculator. y2 equals x squared plus 3x minus -4 +5 is +1. Okay, now you have 2 different equations. This is the first equation here, and this is the second equation. Let's check and see the difference between them and the translation between the first and the second one. X squared plus 3x minus 4. The second one is x squared plus 3x plus 1. Let's make the first equation bold line like this. Okay, if you click enter here, see the lines are different. So the first one is going to be bold and the second one is going to be regular line. When you graph them, this is the first, this is the second. You see the translation here is going up. This is one way to confirm your answer, is the function is going up. And of course, it's going to go up by the number of points we have here. Another way to check if it's going to go up by 5 or something else is just go to the table, pick any points on the table. This is the x value. y1 represents the first function, and y2 represents the second function. You pick any number here. Let's pick 0. The first one is -4 and the second one is 1. The difference between -4 and 1 is 5. Pick another one. Let's go to 3. 2 is fine. Okay, when x equals to 2, the first function, the value of y is 6, and the value of y of the second one is 11. The difference, 11 minus 6, is 5, which means it went from the first equation from 6 to 11, or it went up by 5 points. That's another way to do it. The third way to find this one is finding the minimum of each function. Finding the minimum of each function. The left bound, where is, you see left bound question mark, which means where is left bound. You move your cursor to the left bound. Where is the right bound? You move your cursor to the right bound of whatever you're looking for. In this case is the minimum. Guess where is the minimum? Here is the minimum. The minimum is -6.25. -6.25. This is y1. Okay. The second equation, you gotta go to find the minimum of the second one. Okay, you see the cursor in here, you want to move the cursor here, you're just going to go up this way. Where is the left bound? Left and right bound, you got to move the left and the right cursors, or the left and right arrows, not the above or the below one. Okay, guess where is the minimum? Here is the minimum, negative, of course we're not going to look for the x-axis, we're looking for the y-axis. -1.25, this is y2. So from y1 to y2, the function increased 5 points up. Okay, you take this 5 points and you move it here. -1 and -3 is the minimum. You go 5 points up, it's going to be -1 and 2. So these are like 4 ways to solve this kind of problem. Work well.